In this example, we've got a triangle, and it seems as though perhaps the triangle itself, all three letters have been left out. So I think that the letter that's missing here, I don't know if this is missing on your notes as well, is D. So that'll be triangle DLY. We have an angle D over here, so that would make sense. And angle L is a right angle. And the cotangent, so now we're given a trig relationship of angle D, is 7/8. We want to find all the other trigonometric ratios for the triangle. When I start these problems, I like to draw a diagram right off the bat. It doesn't really matter whatever orientation of the triangle, what the orientation of the triangle is. So you could have yours, facing up and down, left and right, it doesn't matter. But we do need to label it with what we know. This is the right angle, and that's angle L. We've got triangle DLY. We also know that the cotangent of angle D, so we'll call this theta, we're going to steer our direction or our attention right now towards angle D, is 7/8. And we know also that the cotangent is adjacent over opposite. So if we look at this 7/8 here, we can now say that the adjacent side is 7. So let me do that in some different colors here so that'll stand out to you. Let's see. So we said the adjacent side here was 7, and then the opposite side would be 8. It says find all the other trigonometric ratios for the triangle. That doesn't quite make sense. It should be for that angle right there, because it totally would matter which angle we're looking at. So maybe we'll strike this and we'll say for angle D. So we'll strike that, and we'll just say for angle D. And that makes a little bit better sense in the context of the problem. If we do that now, we need to find the hypotenuse. 7/8, I don't think that's a Pythagorean triple. It might be, but I just can't see it right away. So let's just use the Pythagorean theorem. 7 squared plus 8 squared is equal to, we'll make this H. You could make it C too if you wanted. That's another letter that they use a lot in the Pythagorean theorem. But we'll make it H. H kind of to me stands for hypotenuse. So we've got 7 squared, which is 49, plus 8 squared, which is 64, is equal to H squared. We'll add these two up here. So 40 and 60 is 100. 9 plus 4 is 13. So we've got 113. That's equal to H squared. And we'll square root each side. And then we've got the square roots of 113. I don't think you can break this one down. You can try if you'd like. 113, not divisible by 2, not divisible by 3, totally not divisible by 5. It doesn't end in a 5 or a 0. It's not divisible by 6 because it's not divisible by 2. By 7, that wouldn't work. It's not divisible by 3, so it can't be divisible by 9. Maybe 11. Nope. And you'll see now that our number we're dividing by is bigger than our answer here, and that's a switch. So here it was smaller and then bigger, and now it's bigger than smaller. So you don't have to go any further than that when those values kind of flip like that. So 113 just can't be broken down, and we'll leave that value then as the square root of 113. If we set up our ratios, try that here in a different color. What we'll do then is we'll just do the sine of this angle, and that would be opposite over hypotenuse, which is the square root of 113. And we'll rationalize the denominator here, get that radical out of the bottom, and we've got 8 square root of 113, and then that's going to be over 113. My goodness. And we said that 8 didn't go in, or 8 doesn't have a common factor here with 113, so then that's it. To do the cosecant, you can go to this ratio right here, but I think it's going to be easier to go to this one, the original ratio we set up, because after all, if the sine of theta is 8 over square root of 113, its reciprocal will just be the square root of 113 over 8. You could work at that with this one, but then you're going to have to rationalize the denominator again because the square root of 113 will be down in the bottom, and then you'll do some canceling. It would totally work, but I think it's just easier to go to this original ratio to get the cosecant. The cosine is going to be adjacent, which is 7 over hypotenuse. So we could multiply by the square root of 113 over the square root of 113, and then rationalizing, we would get 113 here on the bottom. Same thing would apply here for the secant. Useful to go back to just 7 over the square root of 113, and if we use our reciprocal relationship there, we'll just take that fraction and flip it, and there you have a square root of 113 over 7. No need to rationalize that or anything. The tangent, that's going to be opposite, which is 8 over 7. And this is a nice check. I suppose you really actually wouldn't have to state this because this one's already kind of found like it was in the original problem here. But I like to do this just to make sure that this problem makes sense. So if I take the tangent and I use my reciprocal, I've got 7 over 8. And if we go back, that's the same cotangent here that we had originally. So it did work out. Hopefully we didn't make any mistakes in there, and everything we can do right now to check it did check out.